Question 1 Cross-account S3 access. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Also, hit the bell icon to get notified of new videos. In this presentation, we will work through exam-style scenario questions for the AWS Security Specialty Certification, focusing specifically on IAM permissions, roles, policies, and resource policies. These questions will test your understanding of how AWS permission evaluation works in real-world scenarios. Let us begin with question 1. A company in account A needs to allow an EC2 instance to read objects from an S3 bucket in account B. The security engineer has created an IAM role in account A with a permissions policy allowing S3 get object on the bucket in account B. However, when the EC2 instance tries to access the bucket, the request is denied. What is the most likely cause of this issue? Option A states, the IAM role trust policy does not allow the EC2 service to assume the role. Option B states, the S3 bucket in account B does not have a bucket policy allowing access from account A. Option C states, the EC2 instance needs a public IP address to access S3. Option D states, the IAM role needs the S3 list bucket permission in addition to S3 get object. Let us analyze the incorrect answers first. Option A is incorrect because if the trust policy did not allow the EC2 service to assume the role, the EC2 instance would not be able to obtain temporary credentials at all. The error would occur during the credential retrieval process, not when accessing S3. Since the question states the instance tried to access the bucket and was denied, the role assumption must have succeeded. Option C is incorrect because EC2 instances do not need public IP addresses to access S3. In fact, best practice is to use VPC endpoints for S3 access, which keeps traffic within the AWS network. S3 access is determined by IAM permissions and bucket policies, not by the presence of a public IP. Option D is incorrect because S3 list bucket is only required to list objects in a bucket, not to retrieve specific objects. The S3 get object permission alone is sufficient to download an object if you know its key. Missing list bucket permission would only prevent listing the bucket contents, not reading individual objects. The correct answer is option B for cross-account S3 access. Both the identity-based policy in the source account and the resource policy in the destination account must allow the access. This is a fundamental principle of AWS cross-account permissions. The IAM role in account A has the permission to perform S3 get object, but the S3 bucket in account B must also have a bucket policy that explicitly grants access to the IAM role from account A. Neither account can unilaterally grant or obtain access to resources in another account. This bidirectional permission requirement is a critical security control that ensures both resource owners and identity owners must consent to cross-account access. Question 2 Permission Evaluation Order. Now let us move to question 2. A security engineer is troubleshooting an access denied error. The user has an identity-based policy that allows EC2 terminate instances on all resources. There is also an SCP attached to the account that allows EC2 star on all resources. However, there is an explicit deny in a permission boundary that denies EC2 terminate instances. What will be the result when the user attempts to terminate an EC2 instance? Option A states, the action will be allowed because the identity policy and SCP both allow it. Option B states, the action will be denied because the permission boundary contains an explicit deny. Option C states, the action will be allowed because service control policies override permission boundaries. Option D states, the action will be denied because SCPs only work with AWS organizations. Let us examine the incorrect answers. Option A is incorrect because it ignores the permission boundary. While it is true that both the identity policy and SCP allow the action, the permission evaluation process checks all applicable policies. The permission boundary acts as a maximum permissions guardrail and contains an explicit deny, which will override the allows. Option C is incorrect because SCPs do not override permission boundaries. These are separate policy types that work together in the permission evaluation process. SCPs define the maximum permissions for accounts in an organization, while permission boundaries define the maximum permissions for individual IAM entities. Both must allow an action for it to succeed, and explicit denies in either will block the action. Option D is incorrect because while the statement about SCPs requiring AWS organizations is technically true, it does not explain why the action is denied. The action is denied due to the explicit deny in the permission boundary, not because of anything related to SCPs. The SCP in this scenario is allowing the action. The correct answer is option B. In AWS IAM permission evaluation, an explicit deny always wins and cannot be overridden by any allow statement. The evaluation logic checks for explicit denies first before evaluating allows. Since the permission boundary contains an explicit deny for EC2 terminate instances, the action will be denied regardless of what other policies allow. This is the most important rule in IAM. Explicit deny overrides everything. Permission boundaries are particularly important because they set the maximum permissions an entity can have, and any explicit denies within them will block actions even if identity policies allow them. Question 3. Trust policy configuration. Let us proceed to question 3. A developer is trying to configure an IAM role that will be assumed by a Lambda function. The developer has created the role with a permissions policy granting access to DynamoDB. When the Lambda function runs, it receives an error stating it cannot assume the role. Which component is most likely misconfigured? Option A states the Lambda function needs an instance profile to assume the role. Option B states the trust policy of the IAM role does not specify lambda.amazonaws.com as a trusted principal. Option C states the permissions policy needs to include STS assume role for the Lambda service. Option D states the Lambda function must be in the same region as the DynamoDB table. Let us analyze why the incorrect answers are wrong. Option A is incorrect because instance profiles are specifically for EC2 instances, not Lambda functions. Lambda functions do not use instance profiles. Instead, Lambda functions are assigned an execution role directly through the Lambda configuration. Instance profiles are a container for an IAM role that can be passed to an EC2 instance. Option C is incorrect because the permissions policy defines what the role can do after it has been assumed, not who can assume it. The STS assume role action is called by the entity assuming the role, but the trust policy on the role is what grants permission for that assumption. You would not add STS assume role to the permissions policy of the role being assumed. Option D is incorrect because Lambda functions can access DynamoDB tables in any region. AWS services can communicate across regions, and there is no requirement for Lambda and DynamoDB to be co-located. The error message specifically states the Lambda cannot assume the role, which is a separate issue from accessing DynamoDB. The correct answer is option B. Every IAM role has two types of policies, the trust policy and the permissions policy. The trust policy defines who can assume the role, while the permissions policy defines what the role can do. For a Lambda function to assume a role, the trust policy must specify lambda.amazonaws.com as a trusted principal in the principal element. Without this configuration, the Lambda service cannot call STS:\assume role to obtain temporary credentials for the execution role. This is a common misconfiguration when creating roles manually rather than allowing the AWS console to create the role with the correct trust policy automatically. Question 4. Resource ARN format. Moving on to question 4. A security engineer creates an IAM policy to allow a user to list and download objects from a specific S3 bucket. The policy includes S3:list bucket and S3:get object actions with the resource ARN:/AWS:/S3::my bucket/star. The user can download objects but cannot list the bucket contents. What is the issue? Option A states the user needs S3:list all my buckets permission to list bucket contents. Option B states the list bucket action requires the bucket ARN without the wildcard suffix. Option C states the policy needs to use S3:list objects instead of S3:list bucket. Option D states the bucket must have a bucket policy allowing the list bucket action. Let us examine the incorrect options. Option A is incorrect because S3:list all my buckets is used to list all buckets in an account, not to list the contents of a specific bucket. This permission would be needed if the user wanted to see all their S3 buckets, but that is not what the question is asking about. Option C is incorrect because there is no S3 action called S3:list objects. The correct action for listing bucket contents is S3:list bucket, which the engineer has included. The naming can be confusing because the API operation is called list objects v2, but the IAM action is S3:list bucket. Option D is incorrect because for same account access, either an identity-based policy or a resource policy can grant access. Since the user and bucket are presumably in the same account, the identity-based policy should be sufficient if correctly configured. A bucket policy is not required for same account access. The correct answer is option B. This is one of the most common IAM policy mistakes for S3. The S3 list bucket action operates at the bucket level, so it requires the bucket ARN without any suffix, which would be ARN:/AWS:/S3::my bucket. The S3 get object action operates at the object level, so it requires the object ARN with the wildcard suffix, which would be ARN:/AWS:/S3::my bucket/star. The policy should have two separate resource entries, one for the bucket level actions and one for the object level actions. When both actions use the same resource ARN with the wildcard suffix, the list bucket action fails because the ARN format does not match what the action expects. Question 5. Secure transport condition. Let us continue with question 5. A company wants to ensure all access to their S3 bucket uses HTTP pages S. A security engineer adds a bucket policy with the following statement. Effect is deny, principal is wildcard, action is S3:**, resource is the bucket and its objects, with a condition that bool AWS:**SecureTransport equals true. After applying this policy, all access to the bucket is denied, even over HTTP pages S. What is wrong with this policy? Option A states the principal should specify the account ID instead of a wildcard. Option B states the condition should check for AWS:**SecureTransport equals false, not true. Option C states the policy should use effect allow instead of deny. Option D states the resource ARN format is incorrect for bucket policies. Let us analyze the incorrect answers. Option A is incorrect because using a wildcard principle in a bucket policy is valid and commonly used for this type of security control. The wildcard means the policy applies to all principals, which is exactly what you want when enforcing a security requirement like HTTPS-only access. Specifying an account ID would limit the policy to only that account. Option C is incorrect because using effect deny is the correct approach for enforcing security requirements. You want to deny insecure access, not allow secure access. Using allow would mean you would need to remove all other allow statements, which is not practical. The deny approach works alongside existing permissions to add a security constraint. Option D is incorrect because the resource ARN format described in the question is correct for bucket policies. Including both the bucket ARN and the bucket/*ARN ensures the policy applies to both bucket level and object level operations. The correct answer is option B. The condition logic is inverted. The AWS SecureTransport condition key is true when the request is made over HTTPS and false when made over HTTP. The policy as written denies access when SecureTransport is true, meaning it denies all HTTPS requests. To enforce HTTPS-only access, the policy should deny when AWS SecureTransport is false, which means it denies HTTP requests while allowing HTTPS requests. This is a common logic error when writing IAM conditions. Always think carefully about what condition you want to match for the deny to take effect. Question 6. Session policy restrictions. Now we will examine question 6. An application assumes an IAM role to access customer data in S3. The role has a permissions policy allowing S3 get object and S3 put object on all objects in the bucket. For security, the application passes a session policy when assuming the role that only allows access to objects with the specific customer's prefix. A developer notices that the session can still access objects outside the customer prefix. What is the most likely explanation? Option A states session policies can only add permissions, not restrict them. Option B states the session policy was not passed correctly in the assume role API call. Option C states session policies do not apply to same account resource access. Option D states the role's trust policy is overriding the session policy restrictions. Let us review the incorrect answers. Option A is incorrect because session policies work by restricting permissions, not adding them. The effective permissions of a session are the intersection of the role's permissions policy and the session policy. A session policy cannot grant more permissions than the role has, it can only further limit them. Option C is incorrect because session policies apply regardless of whether the access is same account or cross-account. Session policies are evaluated as part of the permission evaluation for any action the session takes. They are commonly used in same account scenarios for multi-tenant applications. Option D is incorrect because trust policies define who can assume the role, not what the role can do after assumption. Trust policies are evaluated during the assume role call, not during subsequent API calls made with the session credentials. The trust policy cannot override session policy restrictions. The correct answer is option B. If the developer notices that the session policy restrictions are not being applied, the most likely cause is that the session policy was not passed correctly in the assume role API call. The session policy must be provided as a JSON policy document in the policy parameter of the assume role call. Common mistakes include passing the policy in the wrong format, exceeding the character limit for the policy document, or not including the parameter at all. When a session policy is not passed or is malformed, the session receives the full permissions of the role. The developer should verify the assume role call is correctly formatted and check for any errors in the API response. Question 7. Permission boundary delegation. Let us move to question 7. A company wants to allow developers to create IAM roles for their applications without involving the security team for each request. However, the security team is concerned that developers might create overly permissive roles. What is the most appropriate solution to allow role creation while maintaining security controls? Option A states Create an SCP that limits what actions newly created roles can perform. Option B states, require developers to create roles only through an approved CloudFormation template. Option C states, allow developers to create roles only if they attach a specific permission boundary. Option D states, use AWS config rules to automatically delete overly permissive roles. Let us examine why the incorrect answers are not optimal. Option A is incorrect because service control policies apply to accounts in an organization, not to individual IAM roles. You cannot use a service control policy to limit what a specific role can do. Service control policies set maximum permissions for all identities in an account, which would affect everyone including the security team's roles. Option B is incorrect because while CloudFormation templates can enforce some consistency, they do not provide runtime permission restrictions. A developer could modify the template or create roles outside of CloudFormation. This approach also adds operational overhead and does not scale well with diverse application requirements. Option D is incorrect because it is a reactive approach rather than a preventive one. Deleting roles after they are created can cause application outages and does not prevent the brief window where overly permissive roles exist. It is always better to prevent security issues than to detect and remediate them. The correct answer is option C. Permission boundaries are specifically designed for this delegation use case. You can grant developers the IAM:create role permission with a condition that requires them to attach a specific permission boundary. This permission boundary defines the maximum permissions any role they create can have. Even if a developer tries to attach an administrator access policy to their role, the effective permissions will be limited to what the permission boundary allows. This approach enables self-service while maintaining centralized security controls. The condition would use IAM:permissions boundary to specify the required boundary policy ARN. Question 8. A back tag conditions. Proceeding to question 8. A company implements attribute-based access control using tags. They create a policy that allows users to start and stop EC2 instances only if the instance's project tag matches the user's project tag. The policy uses the condition string equals with EC2:resource tag /project equal to the variable AWS:principal tag /project. However, users report they cannot manage instances even when the tags match. What could be causing this issue? Option A states, the AWS principal tag condition key is not supported for IAM users. Option B states, the users do not have the EC2:describe instances permission to see the instances. Option C states, the string equals condition operator is case sensitive and the tags have different cases. Option D states the EC2:resource tag condition only works with security groups, not instances. Let us analyze the incorrect options. Option A is incorrect because AWS principal tag is supported for IAM users, roles, and federated users. As long as the IAM user has tags assigned, the AWS principal tag condition key will work. This is a core feature of attribute-based access control in AWS. Option B is incorrect as the primary cause because while users do need describe instances to see instances in the console, the question states they cannot manage instances. If they were able to attempt to start or stop an instance, they must be able to see it. The describe permission is typically required but is not the cause of the access denied error for management actions. Option D is incorrect because EC2:resource tag is supported for many EC2 resource types including instances, volumes, snapshots, and more. It is not limited to security groups. This condition key is fundamental to implementing ABAC for EC2 resources. The correct answer is option C. The string equals condition operator performs case-sensitive string matching. If the user has a project tag with value web app and the instance has a project tag with value web app, they will not match. This is a common gotcha when implementing a BAC. To avoid this issue, organizations should enforce consistent tag casing through tag policies or use the string equals ignore case condition operator if case-insensitive matching is desired. When troubleshooting a BAC policies, always verify that tag values match exactly, including case, spaces, and special characters. Question 9. Service Principal Trust. Let us continue with question 9. A security engineer is setting up CloudTrail to deliver logs to an S3 bucket. The engineer has created a bucket policy that allows S3 put object from the CloudTrail service. The bucket policy principal is set to cloudtrail.amazonaws.com, but CloudTrail cannot write to the bucket. What additional element is likely missing from the bucket policy? Option A states a condition requiring the S3:XAMZACL header to be bucket owner full control. Option B states the principal should be ARN:AWS:IAM::CloudTrail::root instead of the service name. Option C states a separate statement allowing S3 get bucket ACL for CloudTrail. Option D states the bucket policy must allow S3:list bucket for CloudTrail to write objects. Let us examine the incorrect answers. Option B is incorrect because the correct format for service principals is servicename.amazonaws.com, not an IAM. ARN CloudTrail does not have an IAM account. It uses a service principal. The format shown in option B is not valid for any AWS service. Option C is incorrect because while CloudTrail does need get bucket ACL permission to verify bucket ownership, many engineers include this but still have issues. The get bucket ACL permission alone does not solve the put object problem. The issue is typically with the put object configuration itself. Option D is incorrect because S3:list bucket is not required for writing objects to S3. List bucket is used to list bucket contents, while put object is used to write objects. These are independent operations, and CloudTrail does not need to list the bucket to write log files. The correct answer is option A. CloudTrail requires that objects it writes to S3 have the bucket owner full control canned access control list. This ensures the bucket owner has full control over the logs even though CloudTrail is the one writing them. Without this condition in the bucket policy, CloudTrail will refuse to write to the bucket because it cannot guarantee the logs will be properly secured. The condition should check that the S3:XAMZ access control list header equals bucket owner full control. This is a specific requirement of the CloudTrail service and is documented in AWS guides for setting up CloudTrail with S3. Question 10. Cross-account role chaining. Finally, let us examine question 10. A company has a security account that needs to assume roles in multiple workload accounts to perform security audits. The security team creates a security audit role in each workload account with the security account as a trusted principal. When the team tries to use role chaining to assume a role in workload account B after assuming a role in workload account A, the operation fails. What is the most likely cause? Option A states role chaining is not supported in AWS and requires direct assumption from the original credentials. Option B states the role in workload account B does not trust the role in workload account A as a principal. Option C states the role in workload account A does not have STS assume role permission for the role in account B. Option D states session credentials from role chaining expire after 15 minutes maximum. Let us analyze the incorrect options. Option A is incorrect because role chaining is a supported feature in AWS. You can assume a role and then use those temporary credentials to assume another role. This is commonly used in hub and spoke security architectures where a central account assumes roles in spoke accounts. Option C is incorrect because the question is about the security team assuming roles in workload accounts, not about the workload account role assuming additional roles. The role in workload account A does not need STS assume role permission for account B's role unless account A's role is trying to assume account B's role, which is not what the security team is doing. Option D is incorrect because while role chaining does have session duration limitations, the maximum is 1 hour, not 15 minutes. Also, a shorter session duration would not cause the assume role call to fail. It would just result in credentials that expire sooner. The operation would still succeed. The correct answer is option B. When you assume a role using temporary credentials from another assumed role, the trust policy of the target role must trust the role you are currently using, not just the original account. In this scenario, the security audit role in workload account B trusts the security account as a principal, but after assuming a role in workload account A, the security team is now operating as that role, not as their original identity. The trust policy in account B needs to include the role ARN from account A as a trusted principal, or it needs to trust the security account root, which would allow any identity from that account. This is a common misconfiguration in multi-account security architectures. Thank you for your attendance. Please consider subscribing to the channel for more questions to prep you for the exam. Please like the video if you found it helpful.